Health Seminar. I'm Shirley Fenton, Managing Director of the Waterloo Institute for Health Informatics Research. Thank you for joining us today for this seminar in the series entitled The Many Facets and Faces of Health Informatics. I'd like to welcome our web viewers and Ontario Telehealth Network sites. This seminar is being recorded and is being broadcast over the web. We ask that you hold your questions to after the seminar presentation so that we can get a real or virtual microphone to you. A very warm welcome to our guest speaker today, Dr. Bill Stead from Vanderbilt University Medical Center. Dominic will introduce Bill in a moment. We're pleased that the Lawson Health Research Institute is also co-hosting these seminars, and I'd like to acknowledge our seminar series sponsors, Borden Ladner Gervais, McKesson, and Healthcare Information Management and Communications Canada. Without these sponsors, we cannot host these seminars. Just to let you know, our next seminar in the series will be on Wednesday, November 26th. We're very honored that Professor Steve Walker will be our speaker. Steve is a professor of healthcare in research informatics at the University of Manchester. He is also the Director of Information Systems at the UK Clinical Research Network. He has many titles. He's also the IS Program Director of the National Institute for Health Research and the CIO of the UK Biobank. In the UK Biobank, he'll be speaking on a sickly child's view on information systems - biobanking, research, and healthcare. This seminar looks at the many different facets of health informatics and some of the key people involved in these areas. So our agenda today will be as follows. Dominic Covey, the founding director of the Waterloo Institute for Health Informatics Research, will introduce our speaker. Bill will speak for 45 to 50 minutes, and then this will be followed by a facilitated discussion. We ask that you hold your question to after his presentation, and please signal to us that you have a question and wait until we get the virtual or real microphone to you. Please position the microphone towards you when you speak so that we can record your question on the video recording. So now may I introduce to you Dominic Covey, who will introduce our speaker.
First of all, Bill, we're very honored to have you here today, and thank you for leaving the warmth of the south for the cold of the north, and for arriving here. I think in looking back and looking out at how we've run this series over the last 6 years, we've had a number of really key people here. And in my mind, in terms of the advancement of health informatics in the globe, the center at Vanderbilt, and particularly the leadership of Bill Stead, has been a key factor. Health informatics at Vanderbilt is a very advanced phenomenon. You'll hear about that a lot today. I believe that in addition to what's actually been accomplished in health informatics, and I hope during the presentation and discussion concepts come up about this, about how it's been led has been really critical. So I just wanted to say thank you for being here, and looking forward to your presentation. The more formal comments here will be made by Famita.
Thank you. On behalf of Lawson Health Research Institute, I'd like to welcome Dr. Stead, who is an Associate Vice Chancellor for Strategy Transformation and Director of the Informatics Center, and McKesson Foundation Professor of Biomedical Informatics and Medicine at Vanderbilt University. Dr. Stead has a very impressive and long bio, which might take me the next 45 minutes, so I won't spend time going through that because I'm sure you want to hear his talk. Having had an opportunity over the last couple of hours to informally discuss Dr. Stead's program of research and his vision, I feel very excited about being here because Dr. Stead is a true architect of change. He's a visionary and a leader in the field, and please join me in welcoming him to what will likely be a very exciting talk. Thank you.
Well, thank you. I will try to live a close step to that introduction. What I want to do this afternoon is to briefly say a few words about Vanderbilt so that you'll understand the context of the work that I'm going to be talking about. And then I really want to talk about how we bring together people, process, and informatics to achieve reproducible results. This will not really be about the computer science of the informatics so much as how we manage that intersection. But first, just a few words about Vanderbilt. Vanderbilt is a private university located in Nashville, Tennessee. It is not old by some standards. It origins about 1876. It has 10 schools, and it has around 6,500 undergraduates, about 5,500 graduate students by sort of scope. Its medical center brings together School of Medicine, School of Nursing, 4 hospitals that are on the geographic footprint of the campus that collectively handle about 52,000 admissions per year, and clinics that handle about 1.2 million outpatient visits per year. It's a major research university. Over the past 8 years, we've gone from 24th in funding by the National Institutes of Health to 10th. So it's a major piece of what we do. We made the decision to launch health or biomedical informatics at Vanderbilt in 1991. At that time, most places thought about healthcare information technology as automation. How do we do something faster or with less people? As we looked at the problem, we didn't think it was an automation problem, because basically the data then showed what has been made even more clear recently, which is that if we know something to do for a patient, if we know a certain set of tests, a certain medicine for a certain condition they have, on average we do it just under 60% of the time. We also know that about 40% of what we do in healthcare is unnecessary. So in essence, it's a little bit better than a coin flip in terms of things that we do, particularly with chronic disease. If somebody has an acute problem and we just need to do something to them to fix it, we're actually pretty good at that. But our ability to do all the things it takes to get good outcomes, we're a little better than a coin flip. So what we really decided in 1991 was our job was to figure out how to bring together information in people in a way that would allow the people to make the right decision to do the right thing, get rid of the 40% we didn't need to do, add back in the 40% we weren't doing, and then maybe, if we got around to it, automate the rest. But really we wanted to focus on decision making. And that's why we decided to make a major investment in health or biomedical informatics at that time. In 1993, we became the third university in the United States to actually grant primary appointments in biomedical informatics. And today, biomedical informatics is the 6th largest department in the School of Medicine with full departmental status, its own PhD program, et cetera. One of the keys has been the fact that we have organized to allow the operation and decision support infrastructure of Vanderbilt to be the laboratory for the faculty and fellows and graduate students in biomedical informatics, which has allowed us to look at problems which we weren't able to solve with sort of traditional IT approaches and come up with other approaches that might work. And sort of the poster child of that has been our approach to an electronic health record. We stumbled across this approach in the mid-90s, and in a period of about 3 months, for less than $500,000, we used sort of a secure Google approach of assembling an electronic health record from all the information that was available about the person in whatever form without requiring first automating the practice. That was sort of the breakthrough. We've had numbers of them since then. But as I said, I don't really want to talk about the computer science part of this, even though that's obviously a big part of what we do. That would be, with the kind of math and computer science team you have here, that would be a little bit like bringing coals to Newcastle. So what I'm really going to talk about is this intersection of people, process, and technology. And to set the stage a bit, we are the only level 1 trauma center in a large geographic area, which means the place that the most sick trauma patients have to go. And this is a picture of the helicopter landing on top of the hospital, and then a patient being an adult patient beginning to be taken care of in the emergency room. We're also the only major provider of tertiary services for children in the region. And this shows you how, with all of today's technology, you have to actually look pretty carefully to see the patient amidst all the technology. And the problem that we're trying to solve, or that I want to talk to you about today, is if you put people on a ventilator, before we started this effort at least, we were having about 10 to 30 cases of ventilator-acquired pneumonia for every 1,000 ventilator days. Now, if a patient gets ventilator-acquired pneumonia, the mortality is as high as 33%. So this is a bad condition to have happen. And there are known practices that if people will just follow, you will significantly decrease that incidence. But how do you do that in a place with this complexity and in a way that is consistent across a patient mix that ranges from premature infants to neurosurgery and trauma? That's sort of the question. And this is a question that stumps most medical people. It's very easy for engineers. So if I have 7 practices, and if I'm able to do each of those practices 90% of the time, what's the probability that I will in fact do all 7 for an individual patient? So is it 90%? 75, 50, 25? Anyone want to hazard a guess? I know that gets almost like dealing with a question, which we're not supposed to do, but okay, silence. 48%. It's 0.9 times 0.9 7 times. So most of healthcare is struggling to get its performance on individual practices up to 60, they're around 60% or below on individual practices. They're trying to get it up into the 90s. Even if they're successful, our ability to do all of them for a patient is less than 50%. So how do we begin to change that is really the question that I want to talk to you about. And in essence, the idea is let's move from expert-based practice to expert-managed, system-supported practice. And I'll tell you, before I get into this, I'll talk a little bit about sort of what expert-based practice is, how it's arisen, and what some of the problems are. And then I want to focus on the challenges that we have to overcome if we're, in fact, going to make that shift. In particular, the challenge of translating evidence into standard practice, this idea of how we get closed-loop control with the human in the loop, and then the challenge of changing culture. So let's focus a minute on the origins of what I mean by expert-based practice. And I think that's a much better term. There are a lot of people, particularly in policy circles, that like the word evidence-based medicine and try to say we need to practice evidence-based medicine. I actually think that term is extremely confusing because expert-based practice is evidence-based. What's missing is we do not systematically apply the evidence. And I think we confuse people because what we do as experts truly does use evidence. It's just not systematic. Well, how does this happen? I'm a nephrologist, a kidney disease doctor in my non-informatics world, and I was trained in a model where I was taught the scientific method so that I would understand how facts were discovered, and I would be able to interpret the literature, and I would be able to learn from my practice. Just think about that for a second. If we're, as an individual, I'm going to learn from my practice, and we wonder why we have variability in practice. And I learned in an apprenticeship model where I watch different experts and learn something different from each of them. Look at the way that we make healthcare decisions. We recognize patterns. So if I see a patient and they've got fever and they've got an infiltrate on their chest X-ray, I may begin to think that they've got pneumonia. And if they have a high white count, that would support the fact that they have an infection. If they have a low white count, that may not mean that they don't have infection. That may mean that the infection is so overwhelming that it's wiping out their immune system. So it's a very complex pattern recognition problem. And we have to deal with uncertainty. Not just uncertain information, but we make very imprecise measurements. I was saying last night, in nephrology, the serum creatinine is one measure of whether your kidneys are working. Well, we don't measure the serum creatinine. That's what we call it, but we measure an approximation, something that correlates with serum creatinine. And when I was growing up, the error of that test was plus or minus 0.3. And the standard numbers were like 0.8 to 1.2. Think about what percent of that result was standard error, and yet we make decisions at that level of uncertainty. And we do it in life and death situations. I mean, if you come into the hospital with meningitis and we don't pick it up, you're going to die. And in a world in which we're to do no harm, because most of the time you don't have meningitis, and most of the time you'll do just fine if we don't do something stupid. So that's part of the culture, and we're doing it in an environment where knowledge is simply exploding, and we're responding to that with ever-increasing specialization and subspecialization. So we've got some people that know more and more about less and less, and others that know less and less about more and more. And no good way to actually knit them together. We work in a multitasking, interrupt-driven workflow. So, I'm sitting there and I deal with the most important thing, and while I'm doing that, I get a notification. I decide, is that now more important? If so, I drop this, I go deal with it, and we just hope I get back to this. That is our workflow. And we're paid for technique-centric piecework, and therefore time is not only our most valuable commodity in terms of our cognitive sense, it's also simply in terms of making a living. That is the expert-based practice model as it exists today. The implications, the consequences of that are that we accept variability. Just think about all of the effort at transparency, giving patients the information to pick the best hospital or doctor. That whole effort is based on the idea that they're different and that one's better than another, instead of that as a system we're going to deliver the best to everybody. Particularly in the technical specialties, we become self-confident, and the data is showing increasingly cynical. There's a great deal of fragmentation and therefore loss of responsibility, with a real denial of our individual contribution to the problem. When we sit down and give clinical teams the data about what they actually do, this is the frequency with which the trauma unit does serum magnesiums on patients in the trauma unit. They are appalled. If I sit down and have a discussion with them around evidence, they'll say, yes, we understand that. Yes, that's what we do. No, we don't need decision support. Well, here is the data. This is what you're actually doing. We don't know because we don't look at the data in their patterns, and appalled every single time. And we know the system doesn't work, but it's not because of us. We each know we're each good. We're all type A personalities, trained at the best places, making the best grades. The other sort of piece of this is there is a total disconnect between these experts that are doing their level best, and they honestly are, to take care of the patient despite the system or despite the non-system. Total disconnect with that in the work we do in the middle of the night to try to make the system better, unpaid, on committees, etc. These two pieces are totally distinct from one another. So that's the problem as it exists today, and that's the reason that our performance as it exists today is, even though we know what to do, we do it relatively rarely. This is now what's going to happen to make the problem, depending on your perspective, either better or worse. Because this is the flat line that shows what this computer can have, the number of facts this computer can handle in one decision. We can recall much more, but that's the number we can actually juggle in one decision we're trying to make. This is what we think is coming toward us. We're already bumping up past that level, and I think that's one of the reasons we get the overuse, underuse, and misuse that characterizes healthcare today. But look at what's going to happen. As best we can tell, by the time we've got the full availability of data that we're going to get from structural genetics alone, haplotypes and SNPs, we'll be dealing routinely with about 10 facts in a single decision. It's reasonable to expect we're going to have a 1 log increase as we add function, RNA, to that, and another log increase as we add the effector mechanism of protein. So what is going to happen with your primary care physician when you sit down with them and you've got the disconnect between that and that? So I think the expert-based model as we know it, the demise is inevitable, and the question is, can we figure out another model that will work? You can ask, well, what's this timeline going to be? We don't know. What we do know is that with today's technology, by 2014, we will be able to do relevant whole-body sequencing for the price of a whole-body CT today. So it's going to be sooner rather than later that we're at least getting the first wave of this problem hitting us. So as we have been trying to work at Vanderbilt to test and develop different strategies for, instead of an expert-based practice, a system-supported practice that is expert managed, where the expert puts their energy into manage the overarching system and then deflects that for the individual patient instead of trying to manage each patient independently. That's the idea. And what we want to be able to do is to bring together, joined at the hip, that expert managed system development with then those same experts practicing within a system that supports them. And our goal is to get to where agreement is required amongst the individuals. You use people, process, and technology together, with the people providing wisdom and judgment, the process providing simplification and standardization, and the informatics providing the decrease in dependence on memory and the forcing function. It's actually getting those three things to work together. We would like to get the desired performance 100% of the time, or we want every failure to be turned into an iterative improvement in the way the system works. So that's what we would like to have. How do you do that? And we've been testing this in a number of particular problems at Vanderbilt, and the one I'll walk through with you is this example of how we handle ventilator management. In essence, at the beginning, you need to pick a population. And a population, by population, we're really saying we're talking about any condition that we want to manage to a consistent outcome. In this particular case, it's a patient on a ventilator. And a particular patient can have multiple conditions that are under management. So we're not thinking of population in a world in which an individual can only be a member of one population. We can pick that because of either the risk. I mean, we were trying to drive down our overall mortality at Vanderbilt. That's one of the reasons we picked ventilator-acquired pneumonia. Going after conditions that have a 30% mortality are obviously a good place to go, or their cost, or just the proven variability. But you've got to pick the population, and you've got to have a clear way of measuring whether somebody's in it or not. You then have to assemble the evidence. And you've got to then sift through the evidence and actually figure out what the set of standard practices are that you want to do. So this difference between evidence and standard practice. You know, when I ran a dialysis unit, I bought a new reverse osmosis machine, which is the equipment that cleans up the water so that we could make the dialysate. Well, it arrived with a manual that said, this is how you sterilize it. That's the evidence. It didn't say what the technicians should do when they came in on Monday morning, because that would be different in every unit, depending on how many shifts you run, which days of the week it is, and so forth. So I had to sit down with the evidence, and I had to write, this is what you do on Monday morning. That's the standard practice. This is what you do on Tuesday morning. So how do you make that transition? And so what we did, and I'll show you some examples of this, we actually sit down and we make a table that shows the variability of the evidence. When I say that to policymakers in the United States, they shudder. The idea that there's variability in the evidence is not an idea that's well understood by people outside of healthcare and informatics. And so what we would do is take a source, and we would make a column for that source, and we would start reading it, and we would make a row for the first practice we came along, and we'd write down the practice, and we'd add in what that source said we should do. We'd come on down the second one, fill out that column. Then we'd take the second source, and we would go through it the same way, and if we came up with, if it missed one of the practices, the first one, we'd leave that space in that column blank. If it added a new practice, we'd add a new row, and so on. And in that process, you relatively quickly, instead of arguing about it, you relatively quickly build a table that shows you the variance in the evidence, and then you basically say, given our resources and patient mix, what do we want to do? Then you sit down a small group of subject matter experts and you say, given that, what is the process that we could use to give us a straw person, of what we could use to reproducibly execute on those practices? And what would be the tools we might need, and what would be the education? At that point, we then begin to test it. In our world, first on whiteboards. We've got a great innovation center that lets us bring groups together and work on whiteboards. And you can quickly reject a bunch of stuff before you've even begun to take the time to make a PowerPoint prototype, but just working on whiteboards. And once we then get to where we've got agreement, we then turn it into we make an attempt at turning it into the IT tools people need, the educational stuff they need, and we try to get it out. Then we begin to try to practice with it, because once we've got the next thing we do is essentially go into a rounding model where we deal with an individual patient and we try it. And we then, once we see the status, we make our changes, and we're in a care cycle. And then in time, we get results out of that care cycle that feed over here and feed back into our system development cycle. So you can think of it as a figure-8 diagram in which we do a cycle of system development, and then we flip into trying to use it. And if it works, we do another cycle here. We then detect a problem, we flip back over here and do a cycle there, and it's a cycle of continuous improvement that we try to work through. So that's at high level the concept. Let me then give you some sort of examples about this challenge that we've talked about of translating the evidence into standard practices. There is no shortage of evidence. These are examples of the different sources that were available for ventilator practices. There is this huge difference between evidence and standard practice. I mean, there is a shortage there. But look at the trouble there evidence. So this is the University Hospital Consortium, and this is the Institute for Healthcare Improvement. So the University Hospital said mechanical ventilated patients are at high risk of developing gastrointestinal bleeding and should receive stress ulcer prophylaxis unless medically contraindicated. Well, that's interesting. What is stress ulcer prophylaxis, and what is contraindicated? The Institute for Healthcare Improvement says stress ulcerations are most common cause of GI bleed in intensive care unit patients. The presence of a bleed is associated with a 5-fold increase in mortality, and therefore prophylaxis is recommended. Again, they don't say what it is. So to go from those general statements, which lump a bunch of different things together, into standard practice, you've actually got to figure out, okay, what is the actionable set of terms? So in our case, if you look at this, really it boils down to, do you have a way to get something in their stomach? Most of these people are not able to take things by mouth, so largely it's a question, is there a tube in their stomach or not? And do you or do you not have gross blood? And then depending on that 4x4 table, these are the classes of intervention that we think are appropriate given our patient mix. With that kind of process, we ended up agreeing on 7 practices. And without going through them in detail, I'll just point out a couple of things. First, if you look at the standards that have been published, most of them have this category of oral care. And you discover that they lump together things that are as different in terms of who would do them and the type of talent it takes to do them as oral swabs, which anybody ought to be able to do, to hypopharyngeal suctioning, which requires a dedicated, well-trained staff member. And so we had to decouple these things so we didn't have more than one role involved or more than one thing at a time by that role. And this turned out to be our set of practices. Another point here is that we felt if we were going to get the type of reproducible performance across our enterprise that we wanted, we had to, for the first time in our life, have one set of practices that could be used from the neonatal intensive care unit to trauma neurosurgery. That meant that we had to increase the complexity so that we could, in fact, do the same thing everywhere. And so we elected, instead of having sedation vacations, just stopping sedation, which you can do with patients that aren't but so sick. And we elected to have physician-ordered every 12 hours Richmond agitation sedation scores. This was a very labor-intensive thing, but it was necessary to let us actually have one set of things that would be individualized to the patient, but that would in fact be a standard practice across the whole place. So that for the first time, I can walk on any unit in this medical center and tell what's going on, no matter what type of patient they've got. Then this idea of an implementation process that would work reproducibly. The real keys to this was the sort of the process. I won't walk through the detail of it. What I want to highlight are these pieces at the bottom. We put more energy into figuring out what would our triggers be that we were not following the practice. Then we put into into figuring out what the practice ought to be. Because if we in fact could get the triggers right so that in real time we would know that we were not doing something, then we would be able to iteratively adapt and improve the practice. And again, this is sort of the idea. So if we've got a person that has a ventilator order, and they don't have the standard bundle in place, we know we got a problem. Because how should we have gotten in that situation? That problem gets more severe if we've managed to get the patient on the ventilator without having the bundle ordered, and it gets increasingly severe with timing. That's sort of the idea behind this, because our idea is to be able to drive improvement. The business of using informatics to decrease dependence on memory. So that once we understood the practices, we then created within our computer-based decision support and order capture system an order set that had a component for each of the elements of the bundle. It's a modular order set. When you click on one of those, so for example, with now pick the stress ulcer prophylaxis, given that 4x4 table that I showed you previously, we've now gone further and given the information we have about the age, weight, et cetera, of the patient, and the information from the pharmacy about what our current supply, different drugs are at this particular point in time, we're actually able now to take it down from a class of intervention to an actually patiently individualized calculation of how you would actually implement each of those conditions. And again, with the sedation score, instead of giving people a range and hoping that they measure things in a standard way, we actually put the specifics of how you would in fact judge that into every single order for that sedation score. So that's a little bit of what we mean by trying to use informatics to decrease dependency on memory. Now this is where the forcing function comes in. This is a thing that was sort of the new informatics innovation in this particular work. It's a thing that I call a process control dashboard, where the previous things that I showed you were decision support that we're putting in a particular professional's workflow, be it an ordering workflow or a documentation workflow. This is a very different view. It sets up above everybody's workflow, and it says, this is the status of each patient against the plan in real time with green, yellow, and red stoplights that, although Don Norman says that I've got to do something other than deal with red because of red colorblind, and we haven't yet solved that one, but be that as it may. It's green if everything there is okay and you don't need to do anything. It's yellow if there's something you need to do but you still got time, and it's red if you've missed doing what we're supposed to do. The key here is this is available to everybody in the workflow. So it's sitting right by the bedside, so the clinical team can come by it, and they know the patient. They can immediately say that practice is inappropriate in this situation, or there's a problem with how we calculated the dashboard. Everything's okay and you somehow don't know it, or I've in fact not done something. And so that without after the fact audits and so forth, we get the feedback just out of rounding to iteratively improve and fix this. And there's a huge piece about culture here. Once we got this up and running, I walked onto one intensive care unit and was sitting down with the nurse manager, and she said, "Whoops, I'm seeing a bunch of red over here. I've got to go see why so-and-so is not doing what they're supposed to do." And I knew we were in trouble. I went to the next unit, and I sat down with the nurse manager. And she said, "Whoops, I'm seeing some red here. I need to go give this person help. They don't usually get behind." And I knew that unit was going to do well. Because this isn't a report card. This is a way that we all understand what we're doing in real time. And I'll say some more about it. As you can see, when we first got this all working, there was an awful lot of red. And as you can see here, we actually have a different stoplight for each piece of the bundle that has to be done for a different person. This one's actually now morphed. This was the whether it had been ordered, which was a thing around the doctor, and whether the patient was where they needed to be. We in the end ended up with a column for the doctor, a column for the nurse, and a column for the patient. So did the doctor order it? Did the nurse do what they needed to do? And could the patient do what they needed to do? That's what it actually takes for everybody to know where we are and in real time where we can help each other get to work as a team and get to the result. So that's a bridge over to this second idea of how we get closed loop control with the human in the loop. I think all of you know that a closed loop system is one where the output feeds back to directly change the input to make the system come to closure. And we have those systems in medicine where we take the human out of the loop. So we've got radiation therapy calculation systems, for example, that are closed loop with the human out of the loop. Something of the kind of care that I'm talking about, given the biological variability and the gaps between what we need to know, you actually do not want to take the human out of the loop. What you want to do is to give the human team the information they need to act as, if you will, the control mechanism in a closed loop cycle. And so just for people that may not be familiar with closed loop, I'm not an engineer, and I find this to be extremely helpful, is just to think about the way a thermostat and a furnace work together. It's almost the simplest of closed loop systems. So you look at, what are the inputs to the temperature in the room? And there are many of them. It's how cold is it outside, it's whether the windows are open, whether there's insulation, and how the furnace is working. But whatever those inputs are, they net out to a room temperature. And by having a control mechanism that is nothing more than a sensor for the room temperature, a way to set your targets, and most modern thermostats also have a way of recording the timing of what it's done in the past and whether it's overshot and undershot. You can actually control all of these. So if the whole system works and somebody now opens a window, the system will discover that it takes more heat to heat things up, and therefore it will undershoot. And it will then extend the time it runs. And it will self-correct, and nobody has to go back and reprogram anything. It's a self-correcting system. That's what we need in healthcare. Well, how do you do that? And I think it's actually conceptually simple. First, we've got to have a complete end-to-end plan for the patient. We've got to know what we're trying to do, and we've got to know what its objectives are. What are we trying to achieve? Process steps. How do we plan to do them? Measures. How will we know? And then we need, in real time, information about our performance. What actions have or have not, what actions that are in the plan have or have not taken place, and what's the status of the result. And the difference between those will tell us the status. That's how we produce the dashboard. Well, the trouble is, how do you get an end-to-end plan for something as complex as a patient with multiple problems? Now, when we think about this in healthcare, we tend to think about planning at the level we write orders. And it is impossible to do a plan at that level. So what you've actually got to do is stop and think about planning in a series of tiers of ever-increasing level of specificity. So we can get an end-to-end plan in a very general way. That will provide the context for us to do a more detailed plan for the component of that we're getting ready to work next, which will provide the context one tier down, again, until you get to keeping everything at a manageable level of complexity while still at high level having the overarching detail we need. So take ventilator management. I don't think there is a single person that knows anything about this problem anywhere in the world that would not agree that the objectives are to minimize time on mechanical ventilation while minimizing complications. You've got to have that balance. If I get this short enough that you end up having to be re-intubated, I've not done a good job. But I think everybody agrees that's the objective, and I believe everybody agrees these are the key things you need to accomplish. They don't agree on how you should accomplish each of these, because that actually differs depending on your patient mix and your resources. And then at this level, I think people agree on how we ought to measure our performance. But again, these are things, since they're at this high level, that you cannot, in fact, measure in real time. These are the long-term important outcomes that we actually can only measure at the end of each episode and monitor as a population. Well, then let's take it down a tier. So if we take the goal-directed sedation and rapid weaning, which are so let's build out this tier down one level of specificity. And what you will see are the kind of standard practices that emerged in our bundle at this level. This idea that at Vanderbilt, because of this spectrum of care, we're going to do Richmond-Ash sedation scores with the physician ordering it every 12 hours, the nurse assessing and correcting plan every 4 hours. If I was a simple community hospital and I didn't have neurosurgery and trauma and didn't have a neonatal intensive care unit, I would do sedation vacations. But so these things should be different in different settings. And how I would measure then the rapid weaning. We used to have a very sequential process, which required a lot of decision making. Do we want to do the assessment? And so forth. We now made it routine. Night shift assessment is done every night on everybody, and so on and so forth. This is the level that manages the process control dashboard. And then you take it down a third level, which is the level that we represent in our order sets, which is the individualization to a patient. And this is what you saw in the order set calculations for the third tier down. If we work in that sort of cascading way, then you can actually see the end-to-end plan. And the process control dashboard that I showed you first with all the red was September of 2007. This was a routine walk-by of the surgical intensive care unit in May of 2008. A lot more green. This shows that this is our performance on all the practices by time of day, by unit, and by individual practice. And so you can see that at that juncture we were beginning to get to where several of the individual practices were in the high 90s. More importantly, we're tracking this thing the orange line that we call the Z100 score. That is the frequency that we're actually getting all 7 things done every time for every patient. We're nowhere close to where we want to be, but we're way ahead of where we were. And the important thing, look what's happened to the ventilator-acquired pneumonia rate. And look, it's not just that it's come down. I picked a slide that didn't have the variability before. As I said, this was bouncing between 10 and 30, and it had been doing that for a number of years. We've taken out a lot of the variability in addition to bringing it down. This one intervention alone, if you very conservatively look at it, has resulted, in a 6-month period, saved $1.6 million and averted on the order of 17 deaths. So these are big changes. The less conservative savings would have said you were dropping between $3 and $4 million to the bottom line and saving about a third more deaths than I mentioned. So that is sort of an example of what it might look like to create a closed-loop process which still allowed the human to make their decisions, because we don't, the mantra at Vanderbilt has been the computer is there to make it easier for you to take care of the patient. We've never mandated using it. We have never mandated that people do what it says. We inform the human and leave the human in control, but we record every data point. And therefore, where people vary, if they in fact improve results, we know to go back and change our standard practices. Where they vary, if they get less good results, we in fact now have the information to either move them or to become more disciplined about it if we want to. So let me just take the last 5 minutes and just talk briefly about the nature of the change that we're going to have to see in healthcare if we're going to, in fact, move in the direction that Vanderbilt has been going. So I described in the early part of the talk the culture that has grown up around people that have been trained the way I have been trained as physician scientists. And I think that these are sort of the differences that I think are going to have to take place. I think we have a good 40 or more years of history that you cannot fix this problem from outside healthcare. There is no way to administratively resolve this problem. People can argue about the different healthcare systems. I've looked at the data. Different systems get different results, but frankly, none of them are what we need or deserve. And so I think in many ways we've been moving things around in ways that make different parts better or worse, and different parts kind of things that we try to control administratively. I think we have got to change this system from the inside, which I believe means we're going to have to recruit and train health professionals differently. We have got to train a group of people that instead of trusting themselves to succeed despite the system, they've got to know their limits and trust the system and the team. We're going to have to use simulators and other techniques to force people to recognize their limits and to be able to live within them. We've got to shift from care that's safe from the masses. This is what the personalized medicine is about. Right now, if you have a condition and there's a drug, but that drug would hurt a lot of people if it was given, and if we don't have a reliable way of distinguishing between the people it would help and the people it would hurt, we can't use it. We've got to shift from that to having enough information about the individual that we can do what's right for them despite the fact it would be wrong for other people. We've got to shift from piecework to managing care for populations and the patient as a whole. And this does not conflict with individualization. What it is a much finer, granular view of what we mean by a population. This idea I'm talking about, shift from expert-mediated use of evidence to systematic, each patient being an experiment with an N of 1, to each patient as a data point in a population. We've got to learn in teams. We are not going to be able to train doctors, nurses, pharmacists, physician associates, nurse practitioners separately, and then expect them to work as teams, each with different values, each with different vocabulary. We've got to learn in teams, and I believe we're frankly going to move to a competency-based portfolio, granular career model that will let people differentiate and have no glass ceilings. But that's another hour's talk. We've got to learn from simulation and outcomes, and we've got to start paying for coordination and outcomes instead of for piecework. There are a lot of people that will say, fine, this will never happen. The different professions at this juncture are a monopoly. I happen to believe that slide I showed you of the data tsunami is going to be the thing that gives us a chance to fix the healthcare system. Because I think it will, even if today's quality were good and the cost was okay and we didn't have changing demographics, we would still implode. And those things aren't good. So I happen to get out of the bed in the morning with a great deal of enthusiasm and belief that we can change this, I think it should be obvious from what I'm saying that informatics is the key enabler. There is no way to do this without informatics. Informatics is not sufficient, but it is absolutely necessary if we're going to make these changes. So at that point, I'll stop and take questions if that's appropriate.
Make comments, and what we'll do is pass the microphone
Here.
on the side. And if you have a question, we'll try to get the microphone to you. Introduce yourself and where you're from.
Stefan Pantasi, I'm a professor in a health informatics program. First of all, just to thank you for a wonderful presentation and many examples of I'm teaching a health informatics course, and I'm going to use this. It's just very good examples to how you would define health informatics and why do I in the first place tend to refer to medical and health informatics as being the context-dependent processing of medical informatics. And you mentioned you did not want to actually touch on computer science relevant material, but you actually did by just demonstrating how context-dependent this is. In computer science, context dependence is also a concept which is very important so thank you for that. I was wondering whether different professionals reacted differently to this, what I recognize being a protocol-based type of approach. For example, nurses versus physicians.
Well, historically, I'll really speak from my experience at Vanderbilt. Historically, this type of work, in particular when we're talking about a reproducible care process and less about a reproducible diagnostic process, historically the physician mindset of that has been, that's a nurse problem, let them solve it. The nurses have tried to, but it isn't a nurse problem. It is a team problem. And we had to bring everybody together. And when we first started this work, we had the CEO of the hospital, we had the chief quality officer, we had the corporate chief nursing officer, all in a room for a whole Saturday, helping everybody see the gap between our performance and our result, and getting team awareness of the product. We had a huge problem here. But except for those people, it was still viewed as a nurse problem. It's only when we got these results that the physician leadership across the enterprise has said, there's something really important here. And so their prior assumption is that it's a nursing problem. I think our data proves that it's a team problem, and the minute we could show them if they would just work this way, we could improve results by over 50%. It's now been adopted, but it takes that kind of tipping point.
Well, let's get a microphone to a person in the back. Bill, could you just take a minute and talk about what you had to go through in terms of process to get the ventilator best practice instituted across the organization?
Well, I can walk through the steps and timeline. So we made the decision to tackle this problem in December of 2006. We assembled the small subject matter team right after Christmas, early January, and we spent 4 weeks getting the evidence table together, the idealized process, and and doing a manual audit of our performance against that process. Then the first Saturday in February, we brought together about 46 people, and they were all of the senior leadership of the medical center, plus the key nurse, physician out of each intensive care unit, plus the key person out of each ancillary. And with whiteboards, we spent that day identifying what didn't seem workable and what had been proposed, and doing rapid cycle iteration on whiteboards. we made a very important decision. We basically said we will accept any answer that we can implement house-wide in 6 weeks. So we turned off healthcare's normal response of wanting a very complex system that would let us work the same way we had worked and get better results. And they basically had to come up with things we really were simple enough that we could do. And then we brought those things up. We did them in March, and then it took us, and at that point everything would have stopped. But it was about May that we got the process control dashboard in place. And that actually allowed us to do the rapid cycle iterative improvement on rounds. It was in September that we got things to the point that we could present them to the leadership of the clinical enterprise, department chairs, all that, and everybody would say, yes, we now believe this. And then it took from then until, and therefore they then all said, this is, you've got to pay attention to this stuff. And then it took from then until about November to get to where we were performing reproducibly, and then it took us the next 6 months to document the impact of that on infection rate.
Wow, in the back.
Thanks, that's a terrific story. I'm interested in knowing a little bit more about your opinion on whether you think this could be rolled out and controlling some of the variability that happens outside of the hospital, knowing that so much of the variability does occur outside of hospitals and healthcare. So you've implemented an IT solution in a hospital with a change management process and tons of support for research and knowledge development. In private practices outside the hospital, there is neither the technology oftentimes, certainly not the expert knowledge necessarily, and certainly not the change management process. So I'm curious about whether, and this is just a personal opinion, I'd be interested in hearing you say how you think that might be rolled out, and whether or not there's the inclination to have their performance measured in the same way and to be subjected to these kind of IT solutions. Thanks.
Very good question. The short answer is I do believe it's applicable. We've been working through a number of the building blocks. One thing we've been doing is using exactly this same kind of process control dashboard to let everybody see where we are on a series of important chronic disease management indicators surrounding diabetics and other sort of fairly obvious populations. And we are beginning to see the same kind of improvement in the percentage of the time at which we do all practices. That's within our own control, the medical group that handles this 1.2 million outpatient encounters. It's not beyond an area we control. I believe you've sort of got to get proofs of concept within areas you control. At the same time as that, we have gone to Southwest Tennessee and used this informatics-based capability to assemble electronic health records. And we've assembled an electronic health record for the 2 million people that live in the 3-county region around Memphis. And we've proven that we can do that for $2 per citizen per year. And we've proven that we can get together all the data out of the 6 competing hospital systems in that region, each of which have their own different commercial vendors for their internal systems. So I think that's beginning to show we're learning how to get information together on a regional basis without some complicated added process and so forth. And we're beginning to figure out how to do the dashboards. Over the next 6 months, we actually are hoping to drive the same kind of agreements around both pre-diabetics, type 1 and type 2, for the patient amongst all of the providers that take care of diabetics that get seen at Vanderbilt, whether those providers are Vanderbilt or not, and support this. And so I guess I'll have to email me in the summer and I'll tell you how we did.
Okay, at the back we have a question from the web.
The web question is, a major challenge of the computerized clinical decision support is integrating algorithms, workflow solutions developed locally into commercially large EMRs that are difficult to change. How do you see us advancing CDSs in this setting?
Well, the first thing I think we have to do is to get better understanding that that deployment of commercial CDSSs alone will not result in the type of process improvement that we're talking about. You cannot insert this technology into a work process that exists and expect to get the results that I'm showing. So the real challenge here is to get to where the institutions that are deploying this technology understand that they're actually trying to support a rapid change cycle in a complex adaptive system. The second thing we've got to do is to help the commercial vendors understand that they're going to have to adapt their products to support a variety of different approaches to inserting decision support information. And so those two pieces have to take place. At this juncture, I would be very cautious about deploying such technology into an institution that hadn't worked out this change process. Leapfrog has now released a tool that will allow people, institutions, to test whether their deployed information systems generate the results that they're intended to do. And the early pilots of that show that the certified products that as implemented are stopping even simple kind of drug-drug interactions less than 30% of the time. So there's a huge problem here, and I think both the healthcare enterprises and their vendors have got to recognize that a change is necessary.
Anybody else over here?
I'm Sarah Germain. I'm Site Chief at Regional Mental Health Care in London, which is a large tertiary mental health organization. And I've been very involved with the long process in trying to implement an electronic patient record, which is citywide and region-wide. One of the challenges I think that we continue to see is the sustainability. So we see huge resources being thrown in, people getting excited, making changes, and then as attention gets focused elsewhere, pulling back. And I wondered if you could speak to what were some of the things that you feel are going to help continue to sustain the focus on quality improvement and continuing to use this technology to improve care.
Well, I think first we've got to recognize that there's been whether there's been overinvestment or underinvestment, there's been a lot of investment in this technology, and there's been little improvement. So I think we need to come to grips with the fact that if we invest in IT, we're going to get IT, and the improvement will be accidental. And we've actually got to start investing in improvement and requiring improvement, and then letting the people that are responsible for producing that improvement invest in the right IT to support it if they think it will help, or hire 1,000 scribes. I don't care how we get the improvement. I want the improvement. Once we understand how to work in a way that works, then you can figure out how to support that with the IT. But putting the IT in and locking a process in concrete when what you're trying to do is getting rapid change is just the wrong solution. So that's one piece of it. The second piece of it is we've got to use approaches that are dramatically less expensive, and that's the purpose of informatics. Our informatics-based approach to assembling the electronic health record took less than 3 months and cost less than $500,000. And that got to where you could browse the information about any of those patients in a very large clinical enterprise. Contrast that to the conventional approach, which is a 2 to 4 year, $6 to $10 million project that never ends. And the reason that happens is people are trying to automate practice first so that they can have the integrated database as a byproduct. Instead of saying, how do we just grab all the information and make it available? And use that as the tool to help people figure out how to re-engineer the process and to support it. We've got to flip this thing around if we're going to be successful.
We had a number of chances to speak over the last day, and one of the questions that you almost asked yourself that I'd ask you to answer for yourself here is, how do we train people so that they're really able to lead this kind of thing, make it happen? And how does it change the way we train people right now? So what do we need to do to create, I put it a different way, I said, what do we do to create lots of Bill Steads? And you laughed at that, but we need people who can lead this kind of change process, and I'm not sure that current training programs do it. Can you comment on that?
Well, first, to be clear, my wife and most of the people who've worked with me would say one of me is enough. But in all seriousness, I don't know, and I don't know because I asked the question. I was trained, I grew up, for those of you that don't know this, I began building my first computer-based record in 1968. So I've been at this for a long time. And in essence, I've grown up with the changes in medicine and the changes in the technology. And in fact, I have done the job of everybody that works for me now at some point along the way. And I think one of the questions, and you were the one that put the words this way, I think you were very correct. How do we begin to shift from training, from training experts that know more and more about less and less? How do we shift from that to where we really start producing generalists that really do understand the complete context and know how to bring together the expertise? When my father was chairman of medicine at Duke, and he required each of his chief residents to read the 6-volume Churchill History of World War II. This was while they were on call 5 nights out of 7, so very popular thing to do. And he simply said Churchill was the best example of the generalist that could get the information out of the techies and figure out what to do. So how do we raise more Churchills? We need them for other reasons also, but I don't know. I think this is a big problem that we have to cope with. I think we need to understand our current method of doing it isn't working. And so I think I would like to see teams of computer scientists, engineers, social scientists, physicians, pharmacists, nurses, spending 20% of their day working in system development, and then each doing their own job supported by the system. And then, I think that's how I would try to tackle it. It may be impractical.
Well, in a way it is, in a way it isn't. If we had a mechanism where we could give people a broad overview of the issues, at least when they were wandering around trying to do things, they would know, oh gosh, there's some work over here, somebody's done this, they'd know about it. So they'd know the, as you call it, the complete context. That's certainly valuable. On the other hand, I don't believe that everybody is suited to be a clone of you. I think that requires a certain persona. Maybe it requires a father that makes you read the 6 volumes of Churchill and build a house by your own hands. That is a certain persona. So maybe we have to distinguish a bit in the training between people who are going to go in one direction versus another, and that not all of us are suited to be leaders, and or at least I'll call it managers of an organization. That may be a thing. I think the other thing is that you might comment on is even further is that fact that you did all these things, that you actually program systems. For example, tell us about your wonderful accounting expertise.
Right. Well, I took over as CIO at Duke, and I was born and raised at Duke and didn't budge from Duke until 17 years ago when I went to Vanderbilt. And so I did all my early medical school faculty, all that stuff at Duke. And in the mid-'80s, I took over as CIO at Duke as a very frustrated user. The first thing I was supposed to solve was the fact that we were in a stuck joint development project for a patient accounting system with IBM. And what I discovered was that the people had this plan for producing the accounting system, and each month, a month had gone by and they hadn't made progress, but they had a project management scheme that told them how many resources they needed, so they added resources. And by the time I got there, they had this large group of people, and I just walked around and I asked everybody one question. I asked them what a bad debt was. And what I discovered was that I had a relatively small group of people that actually knew the question to what's a bad debt. And I said, okay, these are the people that have some idea of the problem we're trying to solve. And so I simply got rid of everybody else. And then I sat that group of people down that knew what the problem was and basically said, okay, what can we do in what time period? And how do we figure out the smallest set of thing that would actually be useful? And let's get that done and then move on. And we began to paint our way out of the box. That is a generalist realistically tackling a problem. Frankly, that's the same way I tackle patients. It is a very similar process. I don't know if that gets at your question.
We limit the tackling of patients here in Canada, but I gather in Nashville that's a thing. There's a question.
Particularly with the Titan 7 and 0.
That's right.
See, it's more of a remark than a question. It's only one part of it, but I would suggest that our reward or recognition system is not appropriate for what you're describing. We need to change some of the ways some of the social aspects of the way we do things. People are often rewarded, as you say, for knowing more and more about less and less, whereas people are often not rewarded for being generalists. As a matter of fact, Churchill Daimler starved to death quite a few times over his career for that very reason.
Yes. Yeah, I understand that. I think if we can figure out, if we can figure out what we want and how to measure it. I am now, in addition to my informatics responsibilities, I'm now a medical center strategist for Vanderbilt. And over the past couple of years, I've been helping the place get its hands around what we call Vision 2020, which is our strategy for the next decade. And in essence, what we're trying to figure out is instead of focusing on inputs, educating people, discovering knowledge, taking care of the small number of people we touch. We don't want to stop doing those things, but instead of that being our goal, how do we figure out what the outputs are? How do we actually figure out what we have to do to change health status? Because that's the problem. But the first thing is when I then sit down with our very excellent faculty and ask the question, if we've got an individual with diabetes, how do we know if we're achieving the best results that can be achieved given their values and resources? We don't know how to, so at the heart of it, I think we've got to begin to start measuring the things that really matter. And then we've got to say, okay, what's the gap between those things? And what new way of working would close the gap? I didn't come to this idea of sort of an informatics-based approach to the electronic health record easily. I believe it was 1988 that I wrote my last paper on TMR, which is a system I was a co-developer of, that was a computer-based practice management system that had the computer-based record as its core. That is by far, in a way, from a computer point of view, the most efficient way to solve the problem if, in fact, you can get a system that will handle all the pieces of what's being done for a patient. But by the time I got to Vanderbilt, I simply knew that however efficient it might be from a computer point of view, it simply didn't scale to highly dimensional data about people that are running around all over the country, getting taken care of by healthcare providers, complementary alternative medicine, et cetera. So basically what I had to come to grips with was what I'd tried to do for 25 years was wonderful, it just would never scale. And so in essence, we've got to ask that thing about how we're trying to tackle healthcare. And then we've also got to, we've got to go, from a university point of view, we've got to go beyond transferring it, putting it out there and hoping we'll get the right uptake. We've got to figure out who we've got to engage with to get the benefit. A much more active role. Now Vanderbilt is big enough that in a way we can encapsulate ourselves from the world and test it and get pieces of it. We're big enough we can afford to incentivize people internally one way and get reimbursed from the outside another way and somehow make it work. So I think we have a chance to prove this, and we've got to get the kind of results we've done with ventilators. That speaks volume. And then I think people will begin to think about how to change more broadly. I mean, I think you can tell from my voice, I actually believe this is doable.
Hi, thank you for this excellent presentation of how to bring together people and information technology. My name is Patricia Beretta, and I have a question around usability and user acceptance. Usability and acceptance of the system by the users. I work with a startup company in the field of healthcare integration, so providing technology, software technology to enable the interchange of patient records and patient information across multiple regions, large regional projects. But in order for that information to be exchanged and healthcare providers from multiple settings to collaborate in their different steps of the care of the patient, you need information to be entered. And it was wonderful to see with the dashboard you presented how people got an immediate feedback of how they're doing with a population they're serving. But how do you approach the right balance of people taking care of the patient, using that information, but also having to enter all of those things they've done and they haven't done, so that it's manageable for people and they don't go into overhead of using the system and can still focus on the patient?
Very good question. At its heart, because of our informatics technique of assembling information from whatever source in whatever form, we actually don't have to have people enter stuff into the system. So we have never required people use the physician order entry system. We have required that all orders get into the system. We've educated people about where it is most important for them to get the decision support. So we've educated them that if they have no time for anything else, try to use it for meds. That's the most important place. But our basic test is, let's hold the bar that our goal is to improve patient care. And let's hold our bar that we're professionals. And therefore, do what's right for patients. And if you think using the system isn't right for patients, fine. We'll get somehow we'll work around it, and we'll come back and ask you what would have had to be different for it to have worked for you. In that process, we get an iterative improvement. So that's philosophically an important piece. The second thing we do is we get people doing the things that are most helpful to them, before we do things that are possibly helpful to someone else. So this business of getting all the information together to where it's accessible, that took no time on the part of the physicians or the other care providers, and it immediately gave them one-click access to everything. We tried to test it. We were unable to contain it. It was rolled out house-wide with an index card. You couldn't stop it. You couldn't stop its uptake long enough to figure out if it was safe. That's an example of something that's usable. We then started using it for intra-team communication, supported by that. In that phase, we saved 20 to 30% of physician time. Prior to that, they were caught in this baton swap. I've got a question. Well, I don't have the information. I set it aside. Got another question. Don't have the information. Set it aside. Once you had the information and ability just to handle simple messaging, you saved them 20 to 30% of time. Then we let them draw in tools. that began to do things like prescription writing. Then you begin to cost them time. But you're costing them time within a mode in which you've already got them comfortable with the technology, you've already saved them time, and now they know this really matters for the quality of my patients, and every physician will do their best to do that. It's this business of getting away from this wholesale automation of practice to this business of iterative evolution of work process supported by technology to make things better. And so, I mean, that's the way we've tried to handle it. And we've simply never required use. And we're able to mine the stuff we need for those dashboards. That's why it took so many cycles, because we're talking about informatics algorithms that are calculating the color of those lights. We're not talking about some human doing it. And if that helps.
Unfortunately, we've now run out of time, but just to cap this off, one of the great possibilities that's come out of today, besides the wonderful discussions and some ideas that we've gained for education and even research, is the possibility that we might, at the University of Waterloo and University of Western Ontario, find opportunities to work together with you. So that looks like an extremely bright possible future that we would very much like to engage you in. But for this time of being here, thank you very much, and it was a great talk.
Thank you for your hospitality.
Well, I'd just like to close off today with a sincere thank you, Bill, before you run away, and give you this gift as our small token of our appreciation. So thank you very much. Such an enlightening talk. It certainly gives us many lessons that we can learn from of your experience, and hopefully we can start to follow in your footsteps. There's so many things that we've learned, and I hope we can all go back and try to do some of the things in our own workplaces to make our healthcare system better. So with that, I'd like to thank you all for coming today. It's been a pleasure to have you as our audience, and I hope you will join us again on Wednesday, November 26th.